In today's lab, we're going to measure the coefficient of both static and kinetic friction between this wooden block and this piece of wood. And we're going to do kinetic two different ways. And, sorry, I misspoke. We're going to do static two different ways and kinetic one way. What we're going to do is we know, well, let's just start with powder. We're going to look for the coefficient of static friction. And if I just pull on this string lightly, it's not going to move. And if I pull harder and harder and harder, eventually it'll move. That spot it starts to move, that's when I overcome static friction. What we're going to do is we're going to measure that directly using a force needle. How this force needle works is when I turn it on, it can tell me how hard I either push or pull on this little hook, and can tell me the exact force in newtons that I'm pulling on it. What I'm going to do is I'm going to get the mass of this block, which is given in the lab, and then I'm going to set this on peak mode. What peak mode does, and let me put it on peak mode, is if I push down and then let go, it'll keep on whatever was the highest value it had. And the idea is that if I'm trying to do static friction, when I pull on this, I'm applying a force F to the right, and I'm pulling this way. Static friction is going to oppose that to the left. But my peak value, whatever that is, that's going to be when I had to pull the hardest. And that's going to be when static friction is the largest. Assuming I pull with no acceleration, which I'm going to do my best to do, if I look at the peak, I'll know that is when static friction maxed. Now you look that this lab has a whole bunch of total mass and mass added. What it is total mass is the mass you add to the block plus the block itself. Right now this is mass added 0. So the total mass is just the mass of the block, m sub b. And I'm going to put this here on peak mode, and I'm going to pull really gently. Hope so I remember to actually put it in peak mode. I'm going to try this again. 0. And the second it starts to move, I'll stop. This is going to give me a reading. That's the maximum value the friction ever hit. And so that value should be right when I overcame static friction. I'm then going to do this by adding more mass. When I say mass added, if you look, the first mass added is 0.1 kilograms, which is 100 grams. So I'm just going to take 100 grams and add it in. Once I add that in, I'm going to take it and go again and get a new value. I'll then repeat by adding more mass. The next one is 200 grams. Now note, I'm trying to pull this as close to perfectly horizontal as I can. If I pull up or down, that's going to put some ramp components into this thing, which is one of the last things we really want. And I'll continue this for all the masses. Now, that's how we get static friction. For kinetic friction, we're going to basically do the exact same thing, but we're going to take it off peak mode. And we're just going to have it read live. And I'm going to do the same thing where I'm just going to pull gently. But this time I'm not going to stop once it stops moving. I'm going to try to move it all the way across at constant velocity as I can. Now, I'm obviously not going to perfectly get constant velocity. And so the numbers on the first gauge are going to kind of jump up and down a bit. I'm just going to take my best to average and get something that seems reasonable in those numbers. For part C of this lab, well, that's going to happen right after a really real jump cut, where it's going to be suddenly I'm like in a different spot and it's going to be like nothing happened. For the next bit, I'm going to once again find static friction, but now I'm going to deal with a ramp. That instead of just having everything nice and flat, I'm going to be lifting this up to various angles, where the side of this has a nice protractor. Whatever this higher piece points at, that's what angle I'm at. And I'm going to find what angle something begins to slide. So whenever it begins to slide, that's going to be when we hit the maximum value of static friction. Now there's a whole bunch of calculations you can do. I'm pretty sure they're in the PowerPoint. But what happens is, as this goes up, the normal force goes from straight up to at an angle. And the component of gravity is still straight down, but we can calculate the component of gravity down the ramp. And what's going to happen is when the component of gravity down the ramp hits the value of static friction, that's going to be when it slides down the ramp. And just like that Mario problem we did in class, that'll happen when the coefficient of friction is equal to the tangent of the angle. Note that mass is not part of it. So what I'm going to do is I'm going to do this for a series of masses. Theoretically, mass shouldn't matter. And for each mass, I'm going to see what angle it slides. Once I find each angle, I'll find the tangent of that angle. Now take the average of all the tangents, and that's my average value for static friction. So here I go with no mass added. So I'm starting right about there, which was about 21 degrees. And then I'll do it with some mass added. And that was closer to 19 degrees. And then I'll do it for more mass added. That was also about 19. Add more mass. Right at 20, which I guess makes sense when I've been getting 19s and 21s. Add more mass. Right at 20 again. Off the picture is the first meter, still right there, that I just slammed all this wood into. And the last one. Pretty close to 20 degrees again. And so we'll take the tangent of each of those angles, then find the average.